At the same time, after each chapter, definitely organize the key point for us. Due to the complexity and the nonlinear rheological properties of plastic, there are many elusive challenges in both development and processing. Therefore, we must focus on intelligent manufacturing with the right equipment to improve production efficiency and energy saving. Next, please let me introduce you the third speakers, Otis Siah, the country manager in Malaysia. Today, he will share with us the trend of the industry robot market in Malaysia, the future trend of traditional automated mass production and intelligent manufacturing. Please give him a warm applause.
Hi everyone, my name is Otis, country manager of Syntec Group, a Taiwanese-based company whose our main product is CNC controller, server system, automation controller, and also industrial robotics solution. Syntec is deeply involved in metalworking manufacturing for decades. We see the trends clearly of transformations of industrial manufacturing. Also, we see the threats coming in rapidly. Our goal here is to support our customer, mainly the small medium industry, to ride on the wave of industrial manufacturing transformation. Today, I would like to share with you about industrial robotics solutions for smart manufacturing and how Syntec can be your trusted technical partner. So what we will discuss today is that I will begin with laying out some facts and trends about the transformations of manufacturing process. And then what are the key elements that needs in order to achieve smart manufacturing? After that, I will jump into a brief introductions of Syntec Groups and also talk about our products so that you can see how we can support you moving forward to smart manufacturing. And lastly, I will put together all the components and focus on a case study about smart manufacturing in metalworking industry. But I believe that the basic development process apply to most industry. So let's get started. First, let's look at some numbers. This is an annual installations of industrial robotics globally provided by the IFR, known as International Federation of Robotics. As you can see, the annual installation of industrial robots is definitely increasing over the years and also expected to keep growing in the short coming futures, just as everyone knows. And let us break the number a little bit here. Here you can see that the light blue color is the annual installations of industrial robots in Asia and Oceania regions. The red color here is the Europe regions, while the darker blues represent America. We can easily notice that it's rather stable or slow growing in US or Europe regions, while it has a comparably higher growing rate in Asia and Oceania regions. If we zoom in a little bit in Asia, we can see that the chart over here is showing the number of robots installed in Asian's market, Southeast Asia. Well, we can see the growth is even significant in Asian regions, as shown in these charts, which with averagely above 15% growing rate. Lastly, let us focus on our own market here in Malaysia, which we can see the demand is high and keep growing, especially with the push by COVID-19 pandemic. There are a lot of shortage of foreign workers here. As a principal company, we understand there are a lot of needs for automation from the market. And everyone in the market also want to step into automations, or more precisely, we want to step into the smart manufacturing. But the questions here will be, what kind of automation solution is suitable for our market and how can we achieve it together? Here, let us take a look on evolutions of manufacturing process. A conventional manufacturing normally involve less or no automations, with high dependence on labor and always causing unstable yet inconsistent output. This is not years ago, but is the current situation of most SME in Malaysia. Also, this kind of conventional manufacturing process always lack of traceability, resulting the decisions making usually based on experience instead of data. Well, it may be okay for now, but it makes the business hard to be inherited or to pass to the next generations. Moving forward, we have involved mass quantity of industrial robots in manufacturing process. It solves a lot of problems such as consistency issue, product quality, and also labor dependency. However, these kind of automations, the robots are designed to do repetitive jobs, and the whole system flexibility is very low. This is this method is only used for mass production factory, which we all know that is only for the big players. However, no matter the conventional manufacturing process for the SME or the mass production method for the big players are out of date. They are not going to meet current market requirements, which is mass customizations production required. Therefore, what we need today is smart manufacturing solutions to able to do mass customizations. That robots are more intelligent than before. With aid of peripheral devices such as vision camera as eyes of robots, AGV as add-on to robot movability, it gives the flexibility to automation system be able to do a lot more, yet easy to change robots' job from time to time. Also, we able to linking between machines, robots, and the system, allow the data to be interpreted by management in real time and accurately. Well, who knows what the future holds? But one thing that seems to be clear is that AI, deep learning, reinforcement learning are really transforming robotics. And it is very likely that these trends will make smart factory fully autonomous in the short future. Well, as an engineer myself, it's very exciting to watch that future, but let us stay on today. So, okay, what are the key components for SME to transform from conventional manufacturing to smart manufacturing? First, the robotic system need to be flexible from the start of the system design so that it can fit the high mix low volume productions. And the robot needs to have peripheral devices options, such as to make it more intelligent, such as vision camera, AGV, LiDAR scanner, RFID, etc. And lastly, the whole system should be affordable and fit for the SME in Malaysian market. Here, I would use metalworking industry as an example to discuss more about it. However, as I mentioned, I believe the concept should hold for most industry. But before we jump into that, let us share a little bit more about Syntec and show you a short video. Syntec is a Taiwan-based company, and we have founded in 1995 by a group of experts in CNC control system. So we started in CNC controller. Later on, we increased our production line into server system, automations, and followed by industrial robotics. A couple years ago, Syntec spin off an independent company, namely Lintech, and that company, Lintech, is focused on industrial robotics solutions. So now, under the same group, we have two brands, which is Syntec as a controller system provider, and Lintech is an industrial robotics supplier. Our group footprints are mainly in Taiwan and China, where main CNC machines makers are, with over 40 branches office for sales and technical support to the local customer. Yet, we also aim to expand our business globally. We have started to expand to global markets since a couple of years ago from US, Turkey, and Southeast Asia. With Malaysia here is one of our direct branch office. We provide sales and technical support for both Syntec and Lintech product to our local markets. And here is a glance at our product line from CNC controller, server system, laser marking system, cloud system, automation controller, and also industrial robot. Our all product and components are aiming to give the factory whole industry 4.0 solutions. Okay, now let's see a case study on metalworking industry. This graph shows that how it is like in a CNC factory. There will be numerous of CNC machines, and they will be attended by numerous operators. And sometimes it's one-to-one, sometimes one-to-two, or sometimes it's one to multi machines. Those machines parts will then be transferred and measured and adjust the tool-wear value back on particular machines to ensure the accuracy of the parts. Later on, the parts or the production numbers, the data will be input manually to the company system. Well, here are a couple of common issues that we all know for conventional manufacturing method in CNC factory. First is highly rely on labor. With the cost of labor is increasing all year globally, especially in Malaysia, we can expect the cost of productions will also increase rapidly over the coming few years. It is hard for SME to compete now, and it will be even further harder in the short coming future with this kind of conventional manufacturing process. And secondly, human factors always weigh into in the inconsistency of the productions, giving higher reject rates. With that being said, even without the labor issues, it makes SME not able to get a larger order due to not able to commit the quantity or the quality of the parts. And lastly, the production's information is not able to interpret by management in real time and accurately. The expansion of factory is very, very challenging for management. To solve the mentioned problems, we can first replace the labor with intelligent robots and link the machines with robots. A robot can attend one or numerous machines, depending on the machining cycle time. A robot can be fixed installations or with slider to move around, or even more, we can put a robot on the AGV that able to attend up to many 10 or 20 machines at a time. The system design can also be flexible. By design, we can allow the user to be easily configured and setting the robot to attend certain machines or not to attend specific machines easily through the user interface. Secondly, we can also implement measurements solutions. It can be contact measurement, non-contact measurements. It can be using robot to do the measurements, automation system with the measurements, or semi-auto measurement, depending on the actual situations and the parts, dimension, etc. And then we can use Syntec measurement apps to allow the user to perform auto compensations in the two-way value back on the CNC machines based on the measure result while the robot is running, meaning that there's no need to stop the robots or stop the productions to input the data. We can ensure the parts accuracy in all time, and also the robot is running non-stop. Lastly, instead of manually entry the data to company system, since all the components are linked together, we can directly upload the data to cloud server. If there are needs, we can also provide solutions such as RFID, labeling system, or laser marking solutions so that the traceability is able to achieve. You can pick out parts and scan it, and then the system will tell you which machine cut it, when it is produced, who or which robot attended the parts, and everything. In this way, a problem is easily found with all the data flow connected. So the downtime of the machines will be minimum. So here I will provide you two references to explain the concepts that we have mentioned previously. First reference is a customer that manufacture microscope parts. This part is machining and produced by 12 machines. Each worker able to attend 2 machines at a time. So it takes 6 workers each shift and totally 12 workers monthly in a conventional method. Our solution for the customer is that we add in a single robot to every 2 machines and make it become a production cell. And one worker is able to attend up to 6 cells at a time, resulting that we need only 1 worker per shift. So totally will become 2 workers a month for the same amount of outputs. So the improvement here are easy to be seen that we have greatly reduced the number of labors and we decrease the labor dependency on this case. Even better, we also decrease the defects rate with the aid of two-way conversation apps, and also we making the outputs more consistent in both quantity and quality. Here, let's take a look on this production cell. First, we have designed a customized finger for a sensitive surface to ensure that the handling by robot is smooth and leave no stresses on part. Secondly, due to the limitations of the space in machines, we have simulated the solutions to prevent any mechanical interference. Also, all the output from cells will be in pre-packing trays. so that we reduce the time required for the next process. And lastly, we also implement cloud solutions and remote two-way conversation apps to this project. Here, let's see another reference. The second reference is the customer that produces parts for a globally well-known power tools provider. Coincidentally, this customer also using 12 machines to run the parts. With conventional method instead, they need to attend by 12 workers monthly. We then combine two machines into a single production cell by adding a single robot, making a line into 6 production cells and attend by only single worker in a shift. For this case, the improvements are very similar to the first reference, and yet it will be the same for all CNC factories. We have reduced the labor dependency, decreased the defect rates, increased the traceability, and also for this customer, we have implemented real-time monitoring system for them as required by the management. And here I will show you a video for this reference. Okay, and that will be all my presentation today. I want to say thank you, and we're looking forward for you to come meet us in MetaText. Our booth is at hall number 3, booth number 3200. Please come and meet us to discuss further on how we can help you to transform into smart manufacturing. Thanks.
Everything above is the sharing from today's 3 speakers, including case study of exclusive technologies and a current analysis of future business opportunities. Our speakers have also shared Taiwan's current overview of smart machinery, energy conservation, and carbon reduction. Thank you for participating. I'm Kiwi, your MC today, and I hope to see you again next time. Bye bye!